Okay guys, so in this video lesson we are going to talk about electrons, and we're going to use the periodic table as a guide, for gathering information about electrons and basic atomic structure for the elements based on their position on the periodic table. There's actually an entire unit where we go over periodic trends and different patterns and categories that are within the table, but we really don't have as much time with the nature of the school year. I'm going to condense that information in terms of what's really important in the highlights. So when we come back from the Christmas break, from the holiday break, in second semester, you guys are going to expect it to be able to write chemical formulas, know the nature of chemical bonding and that sort of thing. And in order to do that, you need to know about electrons, especially and specifically valence electrons. So valence electrons are the outermost electrons. Okay, so in a Bohr model, which you guys have seen this, you actually had a couple on your study guide. So if I was going to draw the Bohr model of sodium, okay, sodium has 11 protons, and its average atomic mass is 23, so it's got 12 neutrons inside of its nucleus. And so it's got 1, 2, 3, and I apologize for the sloppy circles, but that's what it is. It's got 3 energy shells, all right? So these rings that I just drew are the shells. They are the layers in the electron cloud. Anyways, the reason why I know that sodium has 3, and this is something you guys will be expected to know, is because sodium is in period 3. So recall that the periods on the periodic table are essentially your rows. They are what go left to right on the periodic table. Keep in mind that the lanthanide and actinide series are extensions of period 6 and 7. They've just been removed from the table. So we talked about this early in the year. But because sodium, which is located right here, okay, because it is in period 3, that period actually corresponds with the number of energy levels worth of electrons that it has. All right, so this is not it's not on this particular table, but sodium, it doesn't have the atomic numbers and atomic masses, but sodium is number 11 on the periodic table, which means it has 11 protons, and that also means that it has 11 electrons, all right? So the first energy shell of any atom can only hold up to 2 electrons, and this may have been something that you guys learned in physical science. So we're going to kind of bring that knowledge back. So I like to draw electrons as dashes just because they look like negative charges and they're just quick. All right. So energy level 1 will only hold 2 electrons, and now electrons will spread out. Those 2 electrons will spread out to opposite sides. Now, every other energy shell will become filled with 8. So right here we got 1, 2, 3, 4, 5, 6, 7, 8. All right. So at this time, I have drawn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So so again, once you get to 8, you move on to the next shell. All right. Except for energy level 1, it gets filled up with 2 electrons. All right, so this, I'll use a different color. All right, this electron right here is what is known as the valence electron. All right, it is the most important electron in sodium because it is the electron that is in the valence shell. So this right here is what is known as the valence shell. All right, so that outermost energy level is important because it's what's coming in contact with other atoms. All right, and that's how that sodium atom will interact with other atoms, other types of elements, and other matter. So that one valence electron is really important. So, and the thing is, every single element that is in the group with sodium also has 1 valence electron. So valence electron count is really important, and there is a pattern that goes across the table. And the pattern corresponds with these 2 sections of the table. So what you see in yellow on this table, these are known as the main group elements, okay? Main group elements are important because they are very reactive. They are the most common elements in nature and in chemistry. Pretty reactive across the board, these two sections, all right? Now, with these two sections, there is a pattern of valence electrons across the table. So I'm going to write that in, okay? So, valence electron count, group 1, let me change because I did not change my pen. All right, so group 1 has 1 valence electron. So when I write VE, all right, that just means valence electron. And I may not always put that negative symbol next to the E, but VE means valence electrons, all right? Group 2 has 2 valence electrons. Now, we are going to skip over the transition metal section. They are not a part of what we call the main group elements, or sometimes called the representative elements. Now, over here, group 13 has 3 valence electrons. Group 14 has 4, 5, 6, 7, 8. All right, now the exception here in group 18, so the exception here with the noble gases is that helium only has 2 valence electrons, okay? I'm not really sure why they have hydrogen over here, but anyway, so I'm just going to kind of mark this out. I feel like I know why, but we're just going to kind of mark that out for right now. All right, I don't want that to be confusing. All right, so the pattern across the table is 1, 2, skip the middle, the transition section, 3, 4, 5, 6, 7, 8. That is the number of valence electrons, all right? And that's important. You have to know that. Like, it is fundamental for the rest of the year in this class, okay? So here is another image of the periodic table, and it brings up some other things that we need to review or mention. So you'll notice that some important groups from the first unit that we covered at the very beginning of the year are on here. We've got the alkali metals. We've got the alkaline earth metals of group 2. Over here in group 17, these are the halogens. And then right here in group 18, those are your noble gases. So again, remember that these are your main group elements, all right? So that is groups 1 and 2, and then groups 13 through 18. So this is groups 13 through 18 right here, and then groups 1 and 2 over here, all right? Now, and don't forget the valence electron count. It's always 1, 2, 3, 4, 5, 6, 7, 8, with the exception of helium, which only has 2. Now, groups 1 and 2 are important because if you recall from the beginning of the year, these are very reactive, all right, metals. Reactive metals, okay? And then this right here is the most active group, reactive group on the periodic table. This is a very reactive group of non-metals, okay? And then lastly, or I'm going to say lastly, almost lastly, your noble gases are not reactive at all because they are completely stable. Now, this is really important because when we talk about the noble gases, their valence shell is full. So I can give you an example of a noble gas, neon. Okay, so neon is actually right here. It's number 10 on the periodic table. It is in period 2, and I know that's not, you can't really see that right here, but just know this is row 2 or period 2 that neon's in. So neon has 10 protons. Its average atomic mass is 20, so, and I just know this, but if you look at a periodic table, it'll tell you that. So its average mass is 20. That's its nucleus, and it's got 2 energy shells. Recall what I said earlier, that the period number tells you how many shells it has. As far as the Bohr model, you've got 2 electrons in energy level 1. That's 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so remember how I said that other than energy level 1, once you get to the other energy shells, they fill up with 8. So this is important because what we see here, as far as noble gases not being reactive at all, well, here's why. It has a complete and full shell, okay? So when an element has a valence shell that is completely filled with electrons, it is satisfied and stable, all right? So that's why our noble gases are not reactive. They don't need any more electrons in that shell. They're not trying to lose, gain, or share electrons, so that's why they're stable. Okay, so this table is meant to refamiliarize you guys with the different types of elements. So these aren't the groups, all right, or the periods. These span across various periods and various groups, but these are 3 sections of the table that are really important when it comes to chemical bond formation. So this is something you cannot forget. So we're going to learn that there are 2 major types of bonds, and those bonds occur between different types of elements. So for instance, ionic bonding occurs between any metal and a non-metal, okay? And then covalent bonding occurs only between the non-metals. So that's going to be really important for you guys to remember. So make sure that you are tracking the different types of elements. So going kind of tying this in with the things that I previously mentioned in the video is don't forget the valence electron counts. 1 valence electron, 2 valence electron, 3, 4, 5, 6, 7, 8. Remember that these are unreactive. Remember the periods are representative of our energy shells. Okay, so I'm just kind of tying together all of the things that have been mentioned today so far in the video. This has 2 valence electrons. All right, that's just helium. All right, energy shells are dictated, 3, 4, 5, 6, 7, are dictated by the period or row that it's in. For instance, let's see. Well, we'll do an example of that in a second. So don't forget your types of elements. The metals make up most of the periodic table. There's only a few metalloids, and then the right side of the table, that is to the right of the metalloids, is your nonmetals, including hydrogen, which is displaced over here with group 1. The only reason why group 1 is, or excuse me, why hydrogen is in group 1 with the alkali metals is because it has 1 valence electron. All right, and that's really the only reason. Now what? All right. I don't know, it's still recording. Anyways, so I got this up here for you guys. So this is another periodic table, and I don't want this to overwhelm you. There's actually a lot more that I could teach from this, but I'm going to skip over electron configuration this year, at least for now. But there is a takeaway from this, all right? So recall that we said that these 2 sections, okay, of the table are known as the main group elements. So these are further called the S and P sublevel blocks of the table, all right? So your main group elements are groups 1 and 2, which make up what we call the S sublevel block, and then you've got groups 13 through 18, which make up the P sublevel block. Now, so the rest of the other 2 blocks, the D block and the F block, not going to concern ourselves with that right now, okay? And actually there's a whole lot more that goes into it, but for the sake of what we are going to cover, you do need to know, remember how I said the periods are like your energy shells, all right? So the energy shells, okay, so let me take period 3 for a second. So period 3 has 2 sections, the S and the P section, okay? So just know that those S and P blocks are sublevels. So you've got your energy shell, which is energy shell 3, all right? But then there's the 3S and the 3P. So they are just like sublevels of that whole energy shell. We won't get into the dynamics of the sublevels. Just know S block is going to be groups 1 and 2, all right? And then groups 13 through 18 are known as the P block. Okay, so let's wrap it up by putting together everything that was shared in the previous slides. And this is what you guys need to know going forward. It's really important for next semester. So this lesson, which will be our final lesson prior to the break, and what we cover prior to the break is just prepping you guys for semester 2 content so that you can do well in it. So let's review. Valence electron count goes 1, 2, 3, 4, 5, 6, 7, 8 across the table. That is the number of outer electrons that an element possesses. So it is based off groups, okay, and specifically the main group elements, okay. So these are the main group elements, okay. Main group elements are group 1 and 2, as well as group 13 through 18. So your main group elements are these two sections on the table. These two sections on the table, I don't want to use that color. All right, this is called the S block, and this is the P block, okay? So that means this here, this is your P block, this is your S block, all right? So important to know. Now, other thing mentioned is that your period, that is the row, so group tells us valence electron count, row tells us the number of energy shells. So one, 2, 3, 4, 5, 6, 7. All right, so your row will tell you how many energy shells are in that atom. Now, another thing, don't forget the different sections on the table. That these, oops, that's not what I wanted to use. Sorry. That these are our metals, okay, roughly. Okay, so everything I'm kind of shading here, those are metals. That these are our metalloids, okay, roughly through here, and I may have colored over something that was not a metalloid, but you guys kind of get the picture. And then these are our nonmetals, including hydrogen that is displaced, okay? So knowing the metals, metalloids and nonmetals is important as well. And also, don't forget the group names that are of importance, that these are the halogens in group 17, that they are very reactive nonmetals. These are your noble gases in group 18. They are not reactive at all. Your alkali metals, which are over here in group 1, are a group of very reactive metals, as are the alkaline earth metals of group 2. So, to end this lesson, I want to take one element off the table and kind of dissect it, all right? So if I was going to take the element, let's see. If I was going to take the element chlorine, okay? So chlorine, which is right here on the table, number 17, okay, that I'm circling. All right, so it has 17 protons and 17 electrons. That's because the atomic number is 17. Its average atomic mass rounds to 35. So 35 minus 17 is 18. So that means it has 18 neutrons. So this is the rounded average mass. Okay. Now, chlorine is in period 3, so if I'm going to draw a Bohr model of chlorine, it's going to look like this. I'm going to put its proton and neutron count here in the center because they are in the nucleus. It's in period 3, so it's got 1, 2, 3 energy shells. There are 17 electrons, so I'm going to start with energy shell 1, there's 2 electrons, 3, 4, 5, 6, 7, 8, 9, 10. So there's 8 in energy level 2, so I'm going to move to my next shell. 11, 12, 13, 14, 15, 16, 17. So this is a Bohr model of chlorine. I want to point out these are your valence electrons, okay? So they're in your outermost energy shell. And so your valence electrons are important. There are 7. That is not the one I want to use. Sorry. So there is 7 valence electrons. These are important because these are the ones that will engage in chemical bonding for chlorine. And you can even see up here where we said that the group dictates its valence electron count. You can see that it has 7, and sure enough, there are 7 valence electrons. Now, there is something called a Lewis dot structure, which is another way of, like, instead of drawing out this whole Bohr model right here, okay, that you can draw out its Lewis structure. So a Lewis structure is where, and you guys have probably seen this, is where you take the chemical symbol for the element and you only draw the valence electrons kind of boxing in it. So chlorines would look like this. 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons, all right? So in, like, for instance, magnesium, which is in group 2 over here, magnesiums would look like this. 1, 2. It's only got 2 valence electrons. So I've probably seen these, and these we will be practicing with as well. All right. So you guys have a mini quiz over this stuff, as well as something that you will complete tomorrow that is kind of setting up a periodic table so that it has all this information in it.